Okay guys, we're going to do 5.7. Warm-up says, which linear equation represents a line containing the point 1, 3? Go ahead and put me on pause, try this by yourself, and then see if you got it right. If you want to work backwards on this, it's a multiple choice question. So we actually could take this point, which is my x, comma, y point. X is 1 and y is 3, and I could substitute it back into these to find out which one of these works. So if I guessed that choice number 1 was the correct answer, I could put 1 plus 2, substituting 3 in for my y, is equal to 5. Well, 2 times 3 is 6, and 6 plus 1 is 7, and 7 does not equal 5, so 1 is not the correct answer. Substitute it into choice number 2. It says x minus 2 times y is equal to 5. 2 times 3 is 6, and 1 minus 6 is negative 5. Not positive, so choice 2 does not work. Try choice number 3. 2 times x, which is 1, plus y, which is 3, is equal to 5. 2 times 1 is 2, and 2 plus 3 is 5, and 5 does equal 5, so we're thinking choice 3 is the correct answer unless we made a mistake. Let's go ahead and check choice 4 just to confirm that 3 is the right answer. Substituting 1 in for x minus 3 in for y, we get 2 times 1 is 2, and 2 minus 3 is negative 1, and negative 1 does not equal 5. So choice 3 is the correct answer. 5.7 is scatter plots and trend lines. A scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs, normally in the first quadrant. Trends in the data, things that we're going to look for and try to observe so we can make determinations about our scatter plot or our line of best fit. This screen that you're copying down right now is really important and actually has been summarized very well. If you were to plot a bunch of points on a graph, a lot of times when you do it in reality, things that are reflecting something in real life, the points typically don't line up like a line that we're used to seeing in math, or do they necessarily form a particular function like a circle or an ellipse, etc. A lot of times they actually are scattered across the coordinate grid, which we therefore call a scatter plot. If you look at the first picture on the left where it says positive correlation, you should notice that these points are scattered, but even though they're scattered, they look like they're clumping and trying to form a line. They're just not completely linear. They're non-linear, but they look like they're trying to be linear. Because the clump is trying to be linear and it's tilting to the right, it means that it has a positive correlation. That's because the slope of this, if it were a line, would be positive. If you look at the second situation, it looks like they're trying to form a line again, but this glob of points is tilting to the left. So therefore, because it's tilting to the left, it would be a negative correlation. If you get a situation like in the diagram at the right, you have the points that are scattered all over the place. They don't look like they're trying to form a line at all, and therefore there is absolutely no correlation at all between any of the points that you have graphed. Now, understand down below the correlation coefficient, which is represented by the variable r, which you will see down the road when you guys use graphing calculators more. Textbooks do use it too, but that's what they use in the graphing calculator. So the correlation coefficient's denoted by the letter r. The correlation coefficient can be a minimum of -1, which would mean if it was -1, it would mean that it would be a line tilting to the left like this. If it was 1, if the correlation coefficient equaled exactly 1, that would mean that the line would be exactly linear, all the points would line up, and it would be tilting to the right because it's positive. If the correlation is equal to 0, that means that all the points are all over the place, like in the diagram on the top right. But if you look at the top middle, the negative correlation one, we know that it looks like it's tilting to the left, so we know it's negative, which is over on the left side of our line graph here. But it's not equal to exactly -1 because it's not completely linear. So it's somewhere between 0 and -1. So any number that's in between there, which would be like -0.1 or -0.8, would be a good guesstimation for that. Sometimes we can guess a little bit more. Like if you think about -0.5, which would be right in the middle, that might be a pretty good guess, though I'm thinking that they're more linear than not, so maybe it's -0.7 or -0.6. Same with this one. However, it's tilting to the right, so therefore it would be a positive correlation, which would be over on the right, closer to 1. It can't be equal to 1, this correlation up here on the left, because it's not linear. So it would be close to that, which would be like 0.7, 0.8, 0.9. So that's what the correlation coefficient is talking about. Remember, correlation coefficient can never be smaller than -1, and it can never be larger than +1. All right, let's draw a scatter plot for the information below in this table, which shows the altitude of an airplane and the temperature outside the plane. If you look at this table, it's got big numbers for the altitude, and it's got decimals for the temperature, which is the y-axis. So this is going to take us a little bit of patience. Make sure you have graph paper as well. You do not want to do this on regular paper, line paper, and try to sketch it. It would be a nightmare. So we're going to call x is going to be my temperature. Oops, no, you know what? I don't want to do that. I want to do x as my altitude, and y is going to be my temperature. So on your x-axis, you need to have the numbers from 0 all the way up to 5,000. So if I count up by, let's see, 1, 2, 3, 4, 5 boxes, that would be 1,000. And I go up by thousands. It would be 3,000, 4,000, 5,000. I probably could have gone up with more boxes per thousand, but we'll leave it at that. Then on your y-axis, the temperature has the smallest is, let's see, I'm thinking 0.6, and the largest is 40, 60, looks like 61.3. So therefore, we want to go from a small, which we could start at 0, but we want to get up to at least 61, so let's say 65. So maybe we could go by 5s. If we went by 5s, and I went every other box, it would be 5, 10, 15, 20. That's not going to work. I'm going to have to go by 5s every box. 5, 10, let's see, it would be 5, 10, 15, 20, 25, 30 would be here. 35, 40, 45, 50 would be here. 55, 60 would be here. It's a little squashed. Anyway, let's go ahead, make sure you guys, see if you guys can make your spread out a little bit better, it would be better. And if your graph, your grid hopefully is bigger than my grid, which is hard to read, hard to work on. Go ahead and plot your points. 0, 59 is right about there, and you're doing a little bit of guesstimation. 500, 59.2. 59.2 is right about there. 1,000, which is 61.3. Hopefully I'm hitting these right. 1,500 and 55.5, which is right here. 55.5 is right about there. 2,041.6. 2,500 and almost 30. 3,000 and almost 30. 3,500 and 18. 15, 20, it's going to be down a little bit. Let's get rid of this one. 4,000 goes with 26. 4,500 goes with 12.4. And 5,000 goes with 0.6. Alright guys, once you plot your points, you'll notice this is a scatter plot. It looks like they're clumping and tilting to the left, which means that the slope is, the correlation is negative. What you want to do is you want to take a straight edge and you want to connect them with a line. When you connect them with a line, you're going to have to play around with your line, but preferably you want to get your line so that it is as close to as many points as you can possibly be. Obviously, it's never going to hit all the points. So if I was to draw my line, let's say from here to this one, that might be okay. But maybe I could find a better point. Let's try, let me erase that. So you kind of got to play around with these. What if we start with the last one? Nope, I don't like that one. What if I go, I don't like that one either. I'm just going to keep playing around with these. I like that one. Now, obviously, I'm picking this point, and I'm picking, whoops, I guess I'm not. I'm going to redo that. Hold on a second. I was trying to pick the last one, and this one. It's just not hitting exactly. I'm trying to pick this one and this one. So really I'm picking the 1500 point, comma 55.5, and I'm picking the 40, oh no, I guess I'm picking the 5,000 one. I'm going to erase that if I can get to it. So I'm picking this one right here. So those are the 2 points I'm going to pick. Now, once you pick 2 points that you make your line go through, obviously all of us may pick different points, which is okay as long as all of our math validates our answer. We're good. We're going to write those 2 points down, which is the 1500, comma 55.5 and the 5,000, comma 0.6. So let's go ahead and write those down on another sheet. Let's see, we have 1500 and 55.5. So the 2 points I'm picking are 1500 and 55.5. And the other one was 5,000, I don't remember, I gotta go back, comma 0.6. Okay, so go ahead and pick the same points I'm picking just so that you can follow along with me, even though you don't have to pick those particular points. So we're going to label this. This is my first point, x of my first, y of my first, x of my second, y coordinate of my, second. Once you pick 2 points, no matter how ugly they look like this one, you're going to go ahead and find the slope. Remember, the slope formula tells you it's y2 minus y1 over x2 minus x1. So that's going to give me 0.6 minus 55.5 all over 5,000 minus 1,500. Alright, so when you guys subtract this, you're going to end up with negative 54.9 over 3,500. So if you divide those and change it to a decimal, it doesn't come out neat. So let's go ahead and leave it as a fraction. That is your slope. When they want you to write the equation of the line that we built, you're going to use, if they give you a choice, use the y1, y minus y1 is equal to m times x minus x1. That will be your easiest thing. And I'm going to pick one of my points. I'll pick my second one. Substitute in y minus y1 is equal to my m, which is my negative 54.9 over 3,500 times x minus x1. and that's the equation of the